Hello, hello. It is a fine Tuesday still, I think. Making sure. Yes. Tuesday. Yay, Tuesday. Ah, thank you for joining today's bit of a impromptu stream. Today I'm gonna be talking about I think everyone probably heard about our beloved internet having a little bit of a bad Monday yesterday. Thought it would be fun to talk about uh, how how that kind of thing can happen. Um, Luckily, I none of the work that I do, well, not none of it. Most of the critical stuff that I work on a day-to-day base was not impacted by that. But I have worked with AWS before, and I thought it would be fun to kind of read through what happened and talk about it. So let me get my audio fixed so we can have a little bit of some fun background music. We can get started. All right, let me know if that's too loud or too quiet. I'm not quite sure how well it mixes with my voice, so let me know. All right. So, let's level set. Okay, great. Thank you, the Bard, for testing my audio. So, let's bring up the screen right here. Let's see. All right. Let me move myself. Scooch, 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 scooch. All right. So, it's a little bit. I was following the whole situation pretty closely when this happened because, as you might now know, when a critical anything on AWS fails, it has a propensity to catastrophically fail. It's pretty well known in my own industry, but typically, the layperson doesn't really have to like track AWS outages too closely. So I happened to hear about this pretty early in the day, but to level set for most people, you probably would have been impacted by this. Probably just like I know for me, I noticed it browsing Reddit, but kind of any big technology firms. So like I know some folks had issues where they were going to like a doctor's office and maybe the doctor's phone or like booking system or appointment system was down if on their computer. Yeah, a bunch of Twitch streams wouldn't end. I'm not surprised by that. Kind of any big centralized service uh, just was having problems in general. I'm not surprised at all, really, that Twitch especially impacted. I don't know specifically where it runs, but being that Twitch is owned by Amazon, I would not be surprised if it's any or all parts of it run on AWS. So I have a couple of links saved, and I'll share them in the chat. But whenever a large enough incident happens, is typically a company will put out a status page, which I'll bring up in just a second. That just says like, "Hey, here's what's going on." I do this too at work. It's kind of just a way to keep everybody updated whenever something is going on, because as you, as you might imagine, for Amazon, pretty much everybody wanted to know what's happening, what's going on. And when you're a big enough company like Amazon and other businesses are doing business with you, you have something called an SLA, which stands for Service Level Agreement. So typically, a business or another business will agree on a service level that just says something like, you guarantee that my computers that I pay you for will be available, say 95% of the time. So when this kind of thing happens, that eats into your availability time. So it means that typically it'll be referred to as like a percentage of time. So you might hear like 2 nines. That means 99.99% uptime. Many things do not need like super duper high availability because they're not critical. But if you're Amazon, you don't really have that excuse. Kind of everything you do is critical. And we'll get into why Amazon's own SLAs are kind of important in a bit. In addition to like a live update page, a lot of places will use something called a postmortem. Amazon uses or has shared things in the past called post-event summaries, which is very similar. Basically, at least in my own definition, a postmortem is where you blamelessly, and that part's really important, talk about what happened with your different stakeholders. And the stakeholders could be just like your other teammates or your business partners or perhaps your literal stakeholders. Sometimes it depends, but the whole thing is that when something happens like this at this kind of scale, it's never anybody, and it's no one person's fault. Because especially with Amazon, you have to, especially with how big Amazon is, you have to make sure that your system protects you from itself, which is why I probably would have made fun of something like this a couple years ago, but now that I've lived through a similar outage, I have a lot of sympathy for how much pressure you can be under during these. So blameless, make sure that your engineering teams feel comfortable, like bringing up like, here's what happened, here's what could have gone better, because now that you've had this outage, you know, the good thing about an outage, I say, is that you'll never get a test quite like an outage. You know exactly how critical your things are during an outage, and that's like a blessing and a curse. So blameless to keep things to make sure that everything is like in a positive direction, because otherwise it can devolve quite quickly into you did X, you didn't do Y, and that's not super helpful when we just want to make sure that the systems are better for the next time that this happens, because there will always be accidents or errors that happen. You can't, there's no way that you can get around that. Like we can mitigate and we can prepare for things, but things will always happen. There's no way that you can get around that fact of life. Computers are too good at doing what they tell you to do, and sometimes we don't tell them to do the right things. All right, so wow, bring up the status page. So it's resolved by now, which is great, but it did go on for quite a long time, which is pretty abnormal, because typically Amazon, when you get to a point, or really it's not even just Amazon, you get to a certain point of time or duration of an outage, you kind of just call in whoever at your company can fix it. So length of time that it took to solve this problem was quite surprising. So let's get started kind of digging into things, and I'll flip between my notes and the page sometimes, because I'm sure there will be terms that we need to define as we go along. Okay. So I don't know Pacific time, so I will just go in Pacific time here. So October 20th, pretty early in the day, investigating increased error rate and latency for multiple AWS services in the US East 1 region. So let's start with that one. So US East 1 is a AWS region. There are multiple regions in the cloud. Typically, when you have a public cloud, which is specifically a cloud that is available to anybody to use. So there's two kinds of clouds. AWS is a public cloud. So this specific region, I believe, is the oldest one, and it was the one that was built first. So there's a lot of legacy services and like critical infrastructure for AWS that lives there, because that's simply where everything started out. And then back. We will provide another update in the next 30-45 minutes. That's speak for, yeah, we know. Please stop calling us about it. A little, not quite an hour later. Confirm increased error rates in latency for multiple AWS services in the US East 1 region. It might also be affecting case creation. So case creation is basically if you have an account with AWS, when you're having trouble, you go create a case and say, hey, come fix my thing. So it's pretty bad that people lost the ability to create cases. Oh, you can actually create a case through the support API. That's cool. We are actively engaged and working to mitigate and understand root cause. Another, we'll check in 45 minutes. It's not ever a bad thing to give those time estimates too, because it's also helpful to time box yourself if you're troubleshooting a particularly troublesome issue. I've definitely had to do that in the past where like several hours, at this point it's not several hours, but like for me, several hours into an outage, I kind of just need to like make sure that I'm figuring out, or like at least making progress towards fixing things. So rather than like say putting a lot of effort into one solution that may or may not be working, if I time box it myself a little bit and say I'll give myself 30 minutes to figure this out, I'll have a better idea of if that solution is viable or not. And then I can say, yes, this solution is viable. I need another 2 hours to make it actually work. Or I can say that one was not viable. I need 30 more minutes to see if I have a different solution, and so on. At least for myself, it's also useful because I have a tendency to just like tunnel vision on the problem very hard, and it's good for me, but you can see here they're like providing those updates. That's because people are anxious to make sure things are working and wanting to make things right. Okay, we can confirm significant error rates for requests made to the DynamoDB endpoint in the US East 1 region. DynamoDB. Putting that down. This issue also affects other AWS services in the US East 1 region as well. During this time, customers, blah, blah, blah. This is a into the tunnel of it. Yeah. Bard says he's gotten sucked in tunnel vision before. Yeah, I am super, super duper bad about it. So I've started with my team. I will tell them, be like, all right, I like this idea for you, but let's find, you got like 20 minutes. Let me record this song. I don't want any vocals. Yeah, I don't know. Like outages are like a weird thing for me because I find them fun, and I'm like, oh yes, I love this problem that I get to solve. But at the end of the day, really, the business just wants it solved. They don't care about if I'm having a fun time. Fixing the fun things. Ooh, oops, scroll back up. Oop, go back. Okay, so DynamoDB. So in AWS, you can typically deploy. Typically, you'll think of people deploying applications, but people don't need. You need more than just an application to be able to do the things that you need to do for software. So typically, if you are having an application, you'll have some other pieces that live outside of application itself. And those are things like your database, which is where the data goes and lives when you're actually accessing it. So like you log in, like the Twitch, you certainly have an entry in a database somewhere that represents your user and kind of like the data about you that Twitch has. You'll also have, and there's multiple different kinds of databases. DynamoDB is a specific type of database. It is a NoSQL database, so typically you'll have a, when you have a database, you'll have it stored in a certain format. DynamoDB basically does not use that format, and it uses a NoSQL. Literally means they don't use a key value system. That doesn't really have anything specific to do here, but I think the implication here is that DynamoDB itself is an application. So, well, DynamoDB itself is an application that Amazon runs similarly to how other customers run applications on AWS. So it sounds like to me this DynamoDB is running in US East 1. So even if you are a developer and you have deployed your application into multiple regions, so US East 1, US West 1, I can tell how often I use Amazon because I pretty much have only ever used US East 1. But it doesn't, if you have deployed multi-region, but you only have one database typically, if that database only lives in a single spot or in a single region, you're still limited to that region's being available. All right, where? Fix my little Firefox window. The page just updated and that actually fell off their status issues. Come back. I was looking at that. List of events. Yes, please. Please open it up. There we go. Okay, there we go. I did not like that. Excuse me while I fix this real quick. I'm gonna just move this over into Obsidian to make it a little bit easier to read. We're gonna be updating the page while I'm trying to read it. Okay, so this is the same page that I have been looking at, but I just clipped it into Obsidian to make it a little bit easier to read. It's slightly out of date because I took this clipping last night, so it might be a little different from what is on their current website. Let me just grab a new copy real quick. Okay. Oh yeah. Okay. So while I was reading it, they swapped over to from a chronological view from one way to the other way. I'm guessing because it's now officially a past event for them. But I was very confused as to why it was suddenly reading backwards. Okay. Okay, so I'm scrolling down now, but this is the same information. Okay. So, we have identified a potential root cause for the error rates in Dynamo DB's APIs. API is probably one we should do as well. Based on our investigation, the issue appears to be related to DNS resolution of the DynamoDB API endpoint in US East 1. We are working to recover on multiple parallel paths to accelerate recovery. The comment about parallel paths was kind of what I was mentioning about having time boxing things. If you have multiple engineers, it's good to time box everybody because you're kind of doubling the amount of throughput, like troubleshooting throughput you can get through. The quicker you can determine if something is not the problem, the better. Anyway, global services such as IAM and DynamoDB global tables may also be experiencing issues. More talking about can't create support cases. We recommend customers continue to retry any failed requests. Yeah. And then status update time. So okay, so DynamoDB database. ultimately, the kind of database that doesn't really matter. So when you have an application deployed, like I mentioned, you typically know like exactly what your application is. The nice thing about having a database in AWS is, yeah, you can deploy your own, but if you have AWS or Amazon in this case, just run DynamoDB. That's one less thing you don't need to like worry about and don't need to know the details of. It's just a thing that exists there, and you don't really need to care more about it until this happens, I guess. So database service. So API, application programming interface. So an API is basically the opposite of the user interface, if you will. So whenever you are interacting with a website, there are certain things that are going on underneath the hood. So when you go to Amazon.com, you are, yes, loading the interface to show you like the search bar and everything. But there are certain calls that your application or that your browser, for example, are doing to Amazon services. So an API is basically a predefined way for computers to talk to each other. Typically, you'll have an API and you'll call it via an IP and a port value. So that would look something like 192.168.1.1. That's a fake local address, and you would call it over port 443. That means that I'm talking to a service on that lives on this IP address on this thing. There should be a application that has a defined API at the other end that, because we have pre-agreed upon how this API works, it does whatever I need and gives me that data back by invoking the call on this IP and port range. What's the other one? IAM. Identity, I think application management. It's not application identity management or identity app in application management. Some combination of those words. Basically, it's the service that tells that allows AWS to know. Yes, Arden is allowed to call the services that Arden has deployed in AWS because she set up the rules that let her do that. But let's say I have a friend named Lemons and I don't want him to talk to my thing. I can say Lemons user is not eligible to do XYZ. That's kind of how when you see a message like you're not permitted to view this, that's because IAM is saying, or there's some IAM rules that are disallowing that from occurring. Just keep trying. Eventually it should work. Yeah, exactly. Yes. Thank you for being my example. You can confirm significant error rates requests made to the DynamoDB endpoint in US East 1 region. This issue also affects other... oh, I need to remember. I'm scrolling down now. Dang it, Amazon. We have applied initial mitigations and are observing early signs of recovery for some impacted AWS services. Requests might fail. Keep retrying. Yes. you'd be surprised how often do you have retry logic is a question. And that can mean specifically for the applications themselves. Like you can program an application if it's having problems, you can tell the application like keep trying within a certain time frame or what have you. But also this just means like if you're having problems with the website, keep clicking. Not a whole lot of meat in this update. I am curious to see, like they say that there's a DynamoDB maybe in other regions, but I'm still curious. It very much sounds like this DynamoDB, the actual service itself, has some critical part of it is in US East 1. And inside a region, you technically have different availability zones as well, but that's still getting a little too far in the weeds. We'll get there. 227. We're seeing significant signs of recovery. Hooray! Most requests should now be succeeding. Most. They're working through backlog. La 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 la. We continue to observe recovery, etc., etc. Those are all some pretty quick updates, so that's good. 335. Okay, the underlying DNS issue. Oh, that's what I forgot to write down. We'll do that in a second. Has been fully mitigated, and most AWS service operations are succeeding normally now. Some requests might be throttled while we work towards full resolution. Additionally, some services are continuing to work through a backlog of events such as CloudTrail and Lambda. I'll explain what those are. Most operations are recovered. Requests to launch new EC2 instances are experiencing an error rate still. Yada, yada, yada. Okay, so let's talk about DNS. Domain name system. I had a moment where I thought maybe I didn't know what the D stood for. So the DNS is basically how your computer knows Google's website or Google's IP address is 8.8.8.8. How does or DNS is how your computer knows 8.8.8.8 is google.com. So I always like to make a comparison. DNS is like your phone book. So it's how you know which IP address goes to where, because it's not quite as true most days, but most of the time when you're communicating this something, you're not talking directly to google.com, you're talking to the IP address. So the significant thing here about DNS is that it is incredibly complicated how DNS works. I'm not going to try to super duper explain that. But under the hood, there's a concept within DNS called time to live. So basically, you have a DNS record, which is just, if we're going to go back to the phone metaphor, we'll pretend that in this metaphor there is a phone operator still. Every so often you call in and you say, operator, I'm still going to use this lease, or I'm going to lease this address for, let's say, four more hours or something to that effect. A top level record like this would be for much longer, but for example's sake, you'll say, I'm requesting this DNS record for this much longer. The nice thing about these is that you you can push updates. So let's say if I am Google and I need to work on the server that answers to 8.8.8.com, obviously I need to update the server, but I don't want to make it so that nobody can get to it, google.com. That would be bad for me because I still want to have your business if you're trying to visit my site. So what you can do is when you have those records go out, you say, I'm leasing this record for 4 hours or what have you. So that means that once I call in, or my computer calls in and I say, okay, I want to go to google.com, that means that my computer knows not to go call the operator again to get an updated phone number for google.com for 4 more hours. It's a good and a bad thing because when you have an issue with DNS, if you've already pushed a quote unquote bad config, you might be hampered by this time to live right here because if you pushed a bad record out and it's already propagated, and so like in this case I called the operator and I got 8.7.8.8.com, my computer's going to hold on to that record for 4 hours because it was promised to me that would be good for 4 hours. And unless I tell my computer specifically to go pick up the phone and call the operator again because this is not working, it's just going to keep using the IP address that it stored when it was not working. So CloudTrail and Lambda are just different kinds of services that are used by applications. Not super terribly interesting other than to know that like you can kind of bolt them onto your applications if you need the functionality that they offer. It's another one of those things where if you don't really care about how the underlying thing works, you can just say, hey, Amazon, I want the Lambda service. I don't really care about the things. Just give me an API endpoint. And Amazon does whatever they need to do to make that API endpoint available to you. We continue to work towards full resolution, and if you are experiencing issues with the DynamoDB, we recommend flushing your DNS cache. That's what I was referring to when I was talking about telling your computer to recall the operator. That's what flushing your DNS cache means. All right, back to update time. Continuing to work towards full recovery for EC2 launch errors, which may manifest as an insufficient capacity error. EC2. I don't actually know what the 2 stands for, but elastic compute is what the first part stands for. If you know what a server is, an EC2 instance is basically the same thing as a server. It is just an instance of a computer that you can use. We'll leave it at that. So basically, if you have a server that's turned off, you have no ability at this point in the outage to turn it back on, which is not great. Well, probably if your application or your server was down, it's fine, but or if it was down beforehand and it was, I would probably assume that you don't care that you can't launch anything, but that would also be impactful for so like people trying to like developers trying to work on fixing their own things. They wouldn't be able to like launch new development instances. The other bad thing is if an application is using manual scaling. So when you have an increase in capacity or like usage for your application, sometimes you'll manually scale it up using EC2 instances. So you'll add more that way. So if you don't rely on Amazon to scale things up magically for you by paying them to do that, then you're kind of stuck here too with just what you have already out there. Okay, we continue to work to fully restore new EC2 launches in US East once. We recommend you EC2 instance launches that are not targeted to a specific availability zone. So it has flexibility. I'll talk about availability zones in just a sec now. I made a little drawing too. So, I talked about the regions before. Let's see. So this is a very, 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 very simplified diagram. Please don't at me for oversimplifying AWS concepts. So in AWS, this is a single region. Inside the region, you will typically have availability zones. So each of these pillars right here represents an availability zone. It'll be like AZ1, AZ2, and so on. So basically, you have the ability as a engineer or developer to say, all right, I'm going to deploy my app right here. And let's say that my app lives in an EC2 instance. So you can say like, I want it to be in here, or I want it to be in here. Sometimes people will do that because they'll have like multiple of the same app and they say, okay, I just want one of each here. But let's say like it sounds at this point like one of the AZs or one or more of the AZs is having problems. But the nice thing about the AZs is that if I were to kind of like cut it in half, all right here, as to make an example, the AZs technically have have the same things available across them. So it shouldn't matter technically which AZ within the region that I have something deployed in. But if this is for some reason still broken or is degraded, I don't want to just say like use the default and say like, okay, I've always deployed my thing here, I'm going to deploy it here. They're just saying remove those rules and maybe you'll land on somewhere else that that will work for you. Impairment in HTA. This is just different kinds of services that you can get from Amazon. We don't need to go into those. Auto scaling groups. Basically, you can tell Amazon, I will allow this instance to scale up this amount because I have this amount of money. Or you can also say, I only want to launch things in this AZ because some reason. So I would at this point posit that some of these technologies, like the EC2 or however they Amazon themselves manages how that works, I would think that they might be using DynamoDB as their own database or part of the database. I wouldn't be really surprised. This practice, or part of this practice, is like dog fooding, using your own products that you put out there. So I wouldn't be surprised if Amazon is using their own services to provide some other services. Making progress as of 5:48 a.m. Pacific time. Applying similar mitigations to impacted availability zones. As they make progress, customers will see increase in successful number of EC2 launches. Yeah. They have a backlog. So at this point, it sounds like they're making good progress, but they haven't really talked yet still about what actually happened at all. We've applied multiple mitigations. We are rate limiting new instance launches to aid recovery. Rate limiting is when you take some sort of protective action to protect your service in this case. So basically, it's selectively shutting the front door to your service and only letting certain people enter your front door. It's hard to summarize this, but basically, in this case, rate limiting new instances means that if you want to create a brand new EC2 instance that has not existed ever before, they probably didn't let you do that. And only if you have an existing instance that you had already created and was just turned off for some reason, those are probably allowed through. 714. Confirm significant API errors. Pretty sure at this point it was pretty well, and for the most part was cleared, if I'm doing my math correctly, because I think this was like around 11 or 12 my time. Seeing good things. We're seeing positive rates. Basically, they're just counting the number of errors when they see that. So that's just a good way of knowing when there's problems. Is if your users are throwing a bunch of errors, you'll have problems. All right, we're continuing to investigate root cause or network connectivity issues. It's the first time that they kind of like point to a specific technology that are impacting AWS services. We've identified that the issue originated from within the EC2 internal network. We continue to investigate and identify mitigations. So typically, oh man, how do I even? Basically, we're not going to flip over to define this. You can have an internal and an external network. So the internal network here is basically how the instances would communicate with each other and how they communicate with Amazon services. So this is saying the call is coming from inside the house. We have narrowed down the source of network connectivity issues. Root cause is an underlying subsystem responsible for monitoring the health of our network load balancers. We're throttling the requests for new EC2 instances to launch aid and recovery and actively working on mitigation. Okay, that's interesting. So let's go back to Obsidian here. So if we're talking about a load balancer, let's kind of go away from the availability zones here. I'm going to flip-flop between some of the different metaphors and forms because cloud is just hard to make simple. Anyway, so let's say you have my app. I'm gonna zoom in a little bit so I can see my app better. Let's say that I have a copy of my app that runs in USA East 1, and I have another copy of my app that runs in some other place and some other place. And I run all of these different things in different places to make sure that I can tolerate failure, so that if one of these goes bleh, I can route my traffic to one of the happy ones. But how do I do that? I have something called a load balancer. Load balancer that sits in front of my application and will say some user. So user calls my endpoint, and we'll say in this case it's arden.social is my website. We'll use that as an example. So basically, the way that a load balancer works is that you'll have a predefined endpoint on your app, and it's going to be an API endpoint most likely that I described earlier. And we'll just color code or describe that as a little circle that's like the port that's opened where your API is answering. You have something exposed on that port or on your application so that your load balancer can talk from the front, that where it's like answering for people who are asking for arden.social. But that way, if my app right here suddenly goes bleh, these health checks right here is what I'll call them. They are constantly reporting like, hey, I'm good. I'm available to take traffic for the user who's saying I want to visit Arden's website. But as soon as one of these turns bad, it says, oh, I can't take traffic. So what the load balancer will do is it will take the bad one out of the pool. So, and this ideally will happen automatically. So as soon as this reports this, your health check says, uh-oh, I realize that the app isn't running how I expect it to. The load balancer's, okay, I'm closing the door and I will redirect other people to another place. That's pretty bad because what they're saying here is that this, well, let me go back and read this. Responsible for monitoring the health of our network load balancers. So it sounds like either this part that lets the load balancers talk to the app instances was not, or they were not working as intended, or Sometimes load balancers you'll have not sometimes. Load balancers themselves can be deployed with like a health check if you have multiple load balancers for reasons, which is something that is pretty not necessarily surprising at Amazon scale. But if you have no ability to tell that the load balancer itself, or if your load balancer can't tell if anything's healthy, then your user's just stuck at the front door. They can't go anywhere, and they're like, "Hello, knock, knock, knock. May I please come in?" And the load balancer's just like, "Sorry, I don't know how to open doors anymore." So maybe DynamoDB is used. Well, I don't think at this point we know it's DynamoDB specifically. That's just what I heard about yesterday quite a bit. But maybe there's a system that's used in both DynamoDB and in the EC2 instances somehow that service the same traffic. That typically is something we would call that as a dependency. So like if my service requires something from AWS to be up, I'm dependent on them. So if my dependency is down, if it's a hard dependency, then I will be hard down, which means you can't use my thing at all. Taken additional mitigation steps. And now seeing connectivity and API recovery. Hooray! Identified and applying next steps to mitigate launching of new EC2 instances, so they're turning down the throttling, letting more people come in the front door. Lambda is another service that they have. It's many people use. Don't really need to go too deep into that. It's just saying that Lambda was impacted because Lambda uses the load balancer health checks. More progress. Mitigations to resolve launch failures are progressing. And a couple of more availability zones are recovering. Oh, that's a pretty big leap in time. So you see here, there's a gap in when they say that they are going to provide an update when they actually provide an update. I wouldn't be surprised if that's something they talk about in their own post-mortem. Like, why was there a communication miss here? Not necessarily it's bad, but I'm almost certain that people are waiting on the edge of their seats at 12 p.m. for an update from Amazon, and if they don't get one for 15 minutes, it's a very nail-biting 15 minutes. Um, 12:15, continuing to recover. It's interesting that they put in a lot of rate limiting basically to wow. I'm curious what exactly they rate limited. Okay, I will grab water. Actually, I do need to go grab a water. Thank you for reminding me. It's interesting because if it's a DNS error, basically, if you're just slow, I would imagine here they kind of at this point know which instances are not going to run or which ones are like impacted by whatever bad update went out to their network devices. I would guess they have a way of seeing like this traffic probably won't succeed, so I'm just going to turn it off. That way you're not, the computer's not wasting resources processing traffic that is never going to work. And it can focus on just doing what it needs to do to recover. I'm taking my hydration break now. You should as well if you are listening. Refreshing. Service recovery across all AWS instances. Our services continues to improve. Taking off the throttles. More throttles. Services such as ECS and Glue. So you can see here the AWS even talks how about some of their services are kind of like a wrapper for other services. So it's like one service actually is like 3 different other services in a trench coat, which is fine because you don't have to worry about calling those 3 things. But sometimes you'll then end up in a weird scenario where you're like, oh, I use ABCD, and it's just like, oh, you didn't know ABCD actually uses G? Well, G is down, and you're like, all right, well, I don't use G. How was I supposed to know? Well, now you'll know. We have restored EC2 instance launch throttles to pre-event levels. Pre-event. The event. I like to maintain a little bit of whimsy, so I've taken to calling incidents is typically the technical term for when something is broken. I call them situations, and I always will like pull a picture of like Wolf Blitzer. It's a situation room. Anyway, the event is well on its way at this point, and things seem to be progressing in a positive fashion. And it looks like this is their final update that they posted. Between 11:49 p.m. Pacific Daylight Time on October 19th, so I think that's only maybe like 20 minutes before they originally posted the first update to this, so that's pretty good awareness time to know like pretty immediately when something breaks. We experience increased error rates and latencies for AWS services in the US East 1 region. Additionally, services or features that rely on US East 1 endpoints such as IAM and DynamoDB global tables also experienced issues during this time. At 12:26 a.m., that's pretty early in the recovery again. We identified the trigger of the event as a DNS resolution issue. It's always DNS. For the regional DynamoDB service endpoints. After resolving the Dynamo DNS issue at 12:24, services began recovering, but they had a subsequent impairment. It's never not DNS. I know. I flip-flopped a couple times between like it's definitely DNS. I'm like, okay, well if it was DNS they would have fixed it by now, but if it was DNS and then it sounds like maybe something got propagated in between that, it's like ugh. Internal subsystem that is responsible for launching the EC2 instances due to its dependency on DynamoDB. Called it. The internal subsystem of EC2 that launches EC2 instances, yeah, it's dependent on DynamoDB. Interesting. So whatever that launching system is uses DynamoDB as a backend. So I would be almost assuredly, if DynamoDB does not live entirely in US East 1, then either its front door is, or some other bottleneck that only lives in US East 1 is somewhere. Part of recovery efforts, we temporarily throttled some instances, yada yada yada. And then once they fix things, we mentioned earlier some things like Lambda, some other technologies like Kafka or whatever. In addition to having a database backend, sometimes you'll have something called eventing, which is basically like the live processing of messages. So when something like this goes on, your messages can't be processed. They just sit in your queue. So they just sit there and get bigger and bigger. The line gets bigger and bigger. So even after the issue is resolved, you have to work through that queue, which can mean typically like your app has to work a lot harder and use a lot more computing power than it normally would. And that's it. So it's so funny because originally all of these were listed as disrupted, and now it looks like only the one is, and everything else is listed as like, oh, it's just impact or downstream of the impact because of this one guy. So that what that tells me is that every single one of these right here rely on DynamoDB in some way, shape, or form, which isn't surprising. Like I said, Amazon is very not notorious, but well known for dogfooding their own things. Okay, so here, I don't want to talk about your little AI things right now, Amazon. I just want to know your mess. So here's the post-event summary page. It looks like they have not posted the actual official summary yet, but let's take a look at the one of the older ones just to see maybe what we can expect once it's available. So little summary, blah blah blah, that kind of just summarizes everything that happened in that thing. This is kind of the what happened. Service impact, I would say this is the who. You want to kind of characterize like who was impacted. In this case, the who is like the services. So that way you can say like, if I use AWS S3 events, I know I was impacted by this, or if I had problems during this time frame, I know it was because of this issue. In closing, we apologize. These don't always have to be like a sob story, which is not what this is, but like a big old sorry letter. Sometimes it can be very easy to slip into like, oh, we donked up. And really these are supposed to, obviously explain what happened in simple terms. This is a bit of a big read, but Amazon is going to be providing lots of information because their clientele at this point is basically the entire world. So they want to probably answer as many questions in as a concise format as possible. But you want to explain what happened and also say like what are you doing to make it better next time. So like I said, you're never gonna have no issues. It's just not how computers work. But what you can learn from this is like, if I were Amazon, I would be asking myself like, can I make DynamoDB not dependent on US East 1? Or can I do I have the ability to start up like a secondary instance of DynamoDB if the first one gets really sick for some reason? Maybe they already have multiple instances in there. I'm not sure. But it sounds like they only had one thing. Like I said, it could be the DynamoDB. Obviously, it might not be behind a load balancer here, but if we had like, if my app is DynamoDB, if I have multiple copies, this one goes bad, I can shut the front door and move people over. So that's probably the first thing I would look at. DNS is a real toughie though. Once you push a bad DNS update, sometimes you kind of are just stuck on your hands because you have to wait for the time to live to expire. Man, it's been a long time since I used Facebook, but I remember when I still used Facebook, there was an outage that they had that was not the same thing, but they took down their routers that basically not the same thing as DNS, but it also uses a time to live system. And they basically just had to sit on their hands and wait for 6 hours for the time to live to expire, which is not what you want to do when your computer is having problems. It's a certain balance, because you don't want to have to call the phone operator for the updated information a bunch of times, because that takes effort and money, and money in the sense of like compute that your application has to do. Why would you want to call the phone company when I could just be focusing on doing the things I need to do for my business? But wow, so I guess it really was DNS. Here, let's find it. Not DNS. Oh, I'm not signed into my thing. Just for you, Barty. Once it loads, in summary, not DNS. There's no way it was DNS. It was DNS. Can't tell. It's like I said, it's very hard to get DNS right. I'll have to do a video someday on more in depth on specifically how just DNS by itself works, because it's pretty critical. As you can see, if it goes down like this, and if you're a critical enough system, you're kind of SOL. But all right, I think that about covers it. Thank you for stopping in for this impromptu stream. It's always fun to chat about doing internet things. Yeah. I will be back later this week with probably some more Pokemon, and I need to get back into the swing with Grand Bazaar. But I think I was thinking about getting some, what is it? I didn't quite get to the point today of setting up my my VR heads back again, but I have been working on getting that streaming set up. So sometime soon I'll be doing a tour of some spooky worlds in VR chat. But if you have any recommendations for fun VR chat worlds to explore on stream, please let me know. I would love to do that sometime. But thanks for everyone who stopped into the stream. It's really fun to chat about technology and how all that stuff works. But if there's any technology stuff that interests you, let me know. I love to chat about it. All right, we'll leave it there. You have a great rest of your Tuesday evening. Goodbye.